Alright, what's up guys? In this video I'm going to pick up some linear algebra, and I'm going to be talking about adjoint matrices and inverse matrix. So we're asked to find the adjoint of matrix A, then use the adjoint of matrix A to find the inverse. So basically what we're doing is looking for the inverse matrix. So the first thing that we need to do is to verify, first of all, if this matrix is invertible, because if the matrix is not invertible, then it doesn't have an inverse. So the way that we do that is by first seeing what its determinant is. So as long as it's non-zero, then it'll have an inverse. Then we can find the adjoint. But the first thing we need to do is just calculate the determinant, basically. So let's find the determinant of A. Let's get that out of the way first. So I have my 2 by 2 matrix, 2 rows, 2 columns. I'm sorry, it's actually going to be 3, 2, 4, and 5. So to calculate the determinant, well, that's just going to be 3 times 5 minus 2 times 4. So we'll get 15 minus 8, which is 7. So we get a determinant of 7. So the determinant of matrix A is 7, which means that it is in fact invertible. So it does have an inverse. So that's the first thing that you need to be checking for, is to making sure if the matrix is invertible, because if it's not an invertible matrix, meaning that the determinant is equal to 0, then it doesn't have an inverse. So that's the first thing that you need to check. So that's done. Alright, great. So we need the adjoint of it. Basically what we're looking for is the inverse, in other words. That's basically what we're asked to do here. So remember the formula for the inverse in this particular case of our matrix A, which is a 2 by 2 matrix. So the formula is A to the negative first is equal to 1 divided by the determinant of A multiplied by the adjoint matrix. So the adjoint of A, that's what the formula is for the inverse. Now, why is that? First of all, why do we have to check the invertibility of the matrix to begin with? So we know that if the matrix has a determinant of 0, then it's not invertible. And the reason for that is, and the reason why it doesn't have an inverse is because remember that division by 0 is undefined. So the reason why if the matrix is not invertible, it doesn't have an inverse, is because essentially we'd be dividing by 0, which obviously is undefined. So that's why it needs to be invertible to have a inverse, just in case you were wondering. But in this case, we do, so no big deal. But that's just kind of just a little bit of background on it. So the adjoint of A, in this case, we just need the adjoint of A. So the adjoint of A, in our case, the adjoint of A is just going to be 5, negative 2, negative 4, and positive 3. So remember, for the adjoint matrix, or in this particular case, the adjoint of A, basically all you do is you swap the entries along the main diagonal, and then change the sign of the entries along the second diagonal. So in other words, we would swap the D entry with the A entry, swap them along the main diagonal, and then change the sign of the B and the C entry. Okay, you don't switch those, but you change their signs. Okay, so that's how you get your adjoint matrix. So in our particular case here, all I did was I switched the 3 and the 5 along the main diagonal and changed the sign of the entries along the second diagonal of the matrix, or you want to say the second one. So I guess I can call this first diagonal here, that would be diagonal 1. If you want to think about the second diagonal with the one kind of going that way, would be diagonal 2. I'm just kind of just trying to explain it. In this particular case, for our matrix A, we have all positive values here. Don't expect that to always be the case. There will be some cases where you'll have negative numbers in the matrix. So obviously, if the matrix is in fact invertible, it does have an inverse. You'll need to get the adjoint. If it's a 2 by 2, you'll need to change the sign. So let's just say if the B and C entry of the matrix were already negative, well, then they would be positive values. So you do have to pay attention to sign changes. We don't have that problem here, but just be aware of that. So again, really all we're looking for is the inverse. That's basically what we're looking for. I know I'm a little all over the place with this example, but I'm just trying to explain what's going on. So we have a raised to the negative first, and that's going to be equal to 1 divided by our determinant, which was 7, remember? And then we'll multiply by the adjoint matrix, which was 5, -2, -4, and +3. And that'll give us our inverse. And we can actually go ahead and just write the final answer down. Now, notice that our resultant matrix will be of the same order as the matrix that we're working with. So the inverse, a to the negative first, will also be a 2 by 2. It's going to be the same order. So our inverse matrix is 5/7, -2/7, and you want to simplify as well as much as possible. We can't really do that here because 7's a prime number. So we'll have -4/7 and 3/7. 7 doesn't have anything in common with 5, 2, 4, or 3. So there really is no reducing that can be done. So you leave it like that. So that's the inverse of matrix A. So hopefully I was able to explain everything correctly. So just a quick rehash, check the invertibility of the matrix to get the adjoint. Just switch the entries along the first main diagonal. You don't swap the entries of the B and the C entry in the matrix. You leave those alone. All you do is you change the sign. That's it. You don't flip them like you did for your entries along the first main diagonal. But that's the first thing you need to be checking first, is the invertibility. I see so many students that they're already trying to find the inverse, and if the matrix has a determinant of 0, then it doesn't have an inverse in the first place. So that's the first thing that you need to be checking. All right, so that's how you find the adjoint of a matrix, and that's how you find its inverse using the adjoint matrix. All right, so let me know if you got any questions. We will see you next time.